Let's look at another example where we're going to solve for that variable of x, but this time we're looking at it using the standard normal distribution. You'll notice here that in this example, we're told that we want to find the z-scores that separate the middle 63% of a distribution from the area in the tails, and we're doing this specifically to what's called the standard normal distribution. The word standard in front of the word normal is going to be another key word you want to be looking for. Remember that when we have z-scores, in order to find z-scores, we had to zero out the middle. So we zeroed out the mean, and then we changed the standard deviation by 1. So if you think back to a previous example way back when, where we were comparing the SAT scores to ACT scores, we can't do that because they are like comparing apples to oranges. So instead we used z-scores to see who scored better, and we did that by making the mean of my distribution 0 and the standard deviation 1. So this x-axis is now representing a z-score, and this is what we call a standard normal distribution. So when you see the word standard, you need to think the mean is now 0 and the standard deviation is 1. So the question we want to answer says, I need to figure out what these z-scores are that's going to separate the middle 63% from the tails. So the middle 63% is an area. So I'm going to draw two lines that are going to be on either side of my area. And this is the middle area we're referring to. And that area is represented by 63% according to the problem. So what are the z-scores that are representing the left and the right boundary here? Well, this is a normal calculator problem. So moving to the normal calculator, I'm going to close this calculator for a second and show you what happens when I open just a regular normal calculator from scratch. Notice that, let me pull this up here. Notice that this calculator defaults to that standard normal value, the mean of 0 and the standard deviation of 1. So if it's not like that, you have to change it. Now we're looking for between here because that's the graph I drew, and we need an area here of 63%. So we're going to change this to 0.63. Hit enter or compute, and you'll notice that the z-score on the left is going to be negative 0.897, and then because it's symmetric, we're going to have a positive 0.897. So we found these two numbers here using the calculator to be negative 0.897 and positive 0.897. And so we used the calculator to find these x variables, or in this case these z variables, given the area of the problem.